Hi, welcome to our pre-calculus. Today's topic is proving an identity using fundamental trig identities problem type 7. So this is supposed to be the hardest of these, and hopefully by now you have learned the uh, set of actions we go through to prove an identity. So we want to go from one side to the other side by applying a series of actions using those rules. So here I have set of rules: algebra, reciprocal quotient, Pythagorean, odd, even, and then there are some others that are coming down shortly. So what do we see here? Let's see how is our decision procedure made. How do I show that sine over 1 plus cosine same as cosecant minus cotangent? We need to have a look ahead of where we are going. We look at the right hand side. I see this is 1 over sine. This is cosine over sine. So we say right hand side has a sine in the denominator. How can we create a sine in the denominator? I have 1 plus cosine. How does that relate to any sine? Let's see if we remember anything from identities that we had. See if we can, in our bag of tricks, if there is anything that's going to help us get there. So you remember that well, you have 1 plus cosine of x. The question is, what can I do so that I extract some sine out of this? Well, just the identity we talked about multiple times, a product of sum and difference, like 1 minus cosine of x times 1 plus cosine of x. What is that going to create? It's going to be 1 squared minus cosine square of x. So why is that any useful? Well, because this is sine square of x. So we have created a sine in the denominator by manipulating our fraction so that such a thing will come about. Now let's go ahead and see if that's going to be helpful. It never hurts. It never hurts to try it and see where we go. So here I have a fraction, so let me make a fraction. So the sine of x, I multiply it by 1 minus cosine of x. In the denominator, I had 1 plus cosine of x. I have to multiply my numerator and denominator by the same thing. So I multiply also by 1 minus cosine. So this factor is multiplied the numerator and denominator of this thing. I have as yet not done any trigonometry. I've just done algebra. So I say I did algebra. Next I say the denominator is 1 minus cosine of x. So again I need a fraction. Let's do that. So I have sine of x. Let's multiply numerator minus sine of x cosine of x. Denominator I have 1 minus cosine square of x, so 1 minus cosine square of x. So all we did here is just more algebra. Then this line is incorrect. What is incorrect about it? Let's see. Oh, I see. I have a typo here. I was supposed to write sine of x. I have just written sine, which is, of course, incorrect. So let's try again. So I corrected my error. Sine of x times 1 is sine of x. Sine of x times cosine of x. Denominator, I did that, and then let's see, are we okay? Well, good. Now denominator can be written as, so let's write numerator is sine of x minus sine of x cosine of x. denominator is sine square of x, and in doing that we just use the Pythagorean, is that right? Because 1 minus cosine square is sine square. That is, now I divide term by term, meaning divide sine by sine square. So what am I gonna do here? Let's sine over, let's just go ahead and yeah, I have here, I have sine of x minus sine x cosine of x over sine square of x. I'm going to write this thing as sine x over sine square of x minus sine x cosine x over sine square of x. It's called fraction decomposition, like opposite of taking common denominator. You can split a fraction as if you had a minus b over c. You can write it as a over c minus b over c. That's what we did. Now this is going to be 1 over sine of x, and this is going to be cosine of x over sine of x. 1 over sine of x is called cosecant of x, and this is cosine of x over sine of x. Now when you do by handwriting, you do all of them at the same time. Here, just to be on the safe side, we do it step by step so that the software doesn't object to us. Cosine over sine is cotangent. This is from here to here we are using quotient identities, and from here is a reciprocal identity. So let's see if we can do this set of activities on. So first I'll write a fraction. I'll have sine of x over sine square of x, and then I step forward, and then I have another fraction, sine of x cosine of x, and denominator is sine square of x. What did we do? Just did algebra. No, I made a mistake here. Let's see, sine square of x. So we did algebra, and let's see, is that fine? Yes. Now sine over sine square of x is so that's 1 over sine of x minus the other one is another fraction. I have cosine of x over sine of x. So what did we do? We just did algebra again. Now 1 over sine of x is cosecant of x minus a fraction, so cosine of x over sine of x. So because we are allowed one rule at a time, so we are stuck with that kind of a rather strange thing. So we did reciprocal. The next, cosecant of x minus, now cosine over sine is cotangent, you remember that. Quotient identities, quotient identities. Cosine over sine is cotangent. That's what we are doing here. So we are writing cotangent of x, and we use quotient, and there we go. We have our proof completed for us. So we learned something here. Right hand side gave us a clue. It's made out of sines in the denominator. That told us convert this thing to a sign. That made us multiply with 1 minus cosines, called the conjugate of this, and that produced sine square for us, and that opened the door. So It's kind of like playing a puzzle to bring you to the destination. Okay, let's try another one. Looks very similar to something we did. Again, let's just go ahead and do a look ahead as to where we are going to go. So we have cosine over 1 minus sine. On the other side, I have secant and tangent. Well, I remember by reciprocal and ratio identities that this is 1 over cosine and that is sine over cosine. Meaning, on the right hand side, the fraction that is there has a cosine in the denominator. But here I have 1 minus sine. How can I go from 1 minus sine to cosine? Well, we remember the Pythagorean identity again, that 1 minus sine square is cosine square. Let me just go on over paper with this thing with you and then come back and do it here. And I recommend that you do the same thing, that is, just take the paper and write the problem on it and work it out there and come back here. Do not try to save time by just clicking. Kind of need to wean yourself off of the keyboard. So what is involved here? Let's write down. So we have what, cosine of x over 1 minus sine of x, and we want to show that that is secant of x plus tangent of x. Our restriction on that software is that you can use one rule at a time, and there you go from left to right. Well, in actual mathematics you can go from right to left or left to right, or you can take both of them to some middle ground. Those are all possibilities, and sometimes one of them is faster than others. But here we are going to go by software requirements. Here I said this is 1 over cosine, and this is sine over cosine. Okay, so really I'm trying to show that this is 1 plus sine of x over cosine of x. And the question is, how do I go from this left to this right? Now I remember that we have 1 minus sine square of x is equal to cosine square of x. Is that right? That's a Pythagorean identity we are going to be used. But then the question is, how do you go from here to here? Many ways of doing this, and one of them is just to go ahead, take your problem. So we have cosine of x over 1 minus sine of x. We take this thing and multiply it by something so that the denominator will become the same. And what is that something? That's 1 plus sine of x. So I'm multiplying by a fraction which is actually just 1. Well, what's the advantage of doing that? The advantage is we are going to apply 1 minus sine times 1 plus cosine. We said that's the identity of a minus b times a plus b. That is a squared minus b squared. Is that right? So that's called, these are called, there's a word for it, they are called conjugates. Sum and difference are called conjugates. When you multiply conjugates, something nice happens. So what happens here is 1 minus sine square of x. Well, what about the numerator? Well, numerator is cosine of x times 1 plus sine of x. Well, for a moment that looks like we made things worse, but now we realize Pythagorean identity tells me denominator is cosine square of x. Numerator is cosine of x times 1 plus sine of x. Now we apply algebra. We say one cosine in denominator, they cancel out. I get 1 plus sine over cosine. Now we apply fraction decomposition, meaning I can, if I have a fraction a plus b over c, I can break it up to two fractions. Why do I want to do that? Because I'm on the right hand side, I want to have two separate pieces, 1 over cosine and sine over cosine. So 1 over cosine plus sine over cosine. Well, 1 over cosine by reciprocal identities is secant. Sine over cosine by quotient identity is tangent. So you notice that when you write it on paper, it looks a bit more meaningful than on the software. But of course, on the software we have the software limitations, and we have to go by the flow. So here we go ahead and so I make a fraction. On the numerator I have cosine of x. We said we multiply by 1 plus sine of x, and denominator we had 1 minus sine of x. We multiply that with the same thing, 1 plus sine of x. So all that we have done, doing some algebra. Are we okay? Let's hope so. Now in the again, let's have a fraction. Numerator as it is, cosine of x times 1 plus sine of x. Denominator, we have 1 minus sine square of x. No, 1 minus sine square over x. What did we do? We just applied more algebra. Are we fine? Let's hope so. Then I have now cosine, well, wait, we have, if I have a fraction, in the numerator I still have cosine of x times 1 plus sine of x. Denominator, now I have cosine square of x. So what did I do? I applied the Pythagorean. Are we fine? Let's hope so. Now I cancel 1 cosine, so still I have a fraction. I have 1 plus sine of x to cosine of x. We might have been able to do two algebra at the same time. We can try it and see if it works. So now I do fraction splitting. That is one fraction, which is 1 over cosine of x, and then I have plus another fraction, which is sine of x over cosine of x. So what did I do now? I have applied just algebra. Try one more time. 1 over cosine is secant of x. Now here comes software limitation perhaps, or you can try to see if it lets you go through. So 1 over cosine is just a reciprocal identity, so I can use that, replace one item. Now secant of x, I keep it. Sine over cosine, I remember that it's tangent of x by the fact that it is the quotient identity. Okay, quotient and reciprocal, two separate categories. And what is it that we wanted to have? We wanted to have that this right hand side is secant plus tangent, and that is what we got, so we should be good to go. So our proof is complete. And so on. So you try more problems here, and let me just mention something that in the list of problems that we have here, in the list of rules that we have here, you see some new items. Many of them don't show up yet, but they'll show up later. We have a lot more identities coming up. In fact, by some count, there are 6 dozen of them. But odd, even, double angle, sum and difference, and so on. We didn't see examples of those, but they are going to show up later on. Just be patient. Now, how about this problem itself? So let's again try to go on paper first, see if so I have what do I have? I had sine square of x over 1 minus cosine of x. I want to show this is secant of x plus 1 over secant of x. Okay, and again, our software asked to go from the left side to the right hand side in one rule at a time. As we said, on paper, you go from left to right. Perhaps you want to go from right to left. Maybe you apply multiple rules at a time. It's a little bit more flexible, but software wants to know your steps, and that's why we are limited. So, how do you go from this to this? We had several problems where we applied the conjugate multiplication. That meant multiply with the denominator's conjugate, whose denominator's conjugate. If it's a difference, it's going to be the sum, and vice versa. Well, what does that get me? What it gets me is that I have sine square of x times 1 plus cosine of x, and this becomes 1 minus cosine square of x. Now 1 minus cosine squared by Pythagorean is just sine squared, and then sine square and sine square cancel out. Notice how much we compressed here. The software is not going to allow you to do that. It just do step by step. So what is left when these two cancel out? When this cancels out this one, all that's left is 1 plus cosine. So that's a lot cleaner than this, but our problem would be incomplete if we don't make it to this destination. Well, how do I make it to that destination? This is in terms of secant. So I remember the reciprocal identities, that cosine is reciprocal of secant, and now from here I see that if I take a common denominator, secant of x, and here's going to be secant of x plus 1, so you're essentially taking 1 and writing it as secant of x over secant of x. Just any 1 can be written as anything divided by itself. So I wrote secant over secant, so I can take common denominator, and now I have my right hand side. So you notice I take this and convert it to that. That's the idea of identity, going through a sequence of legal steps to take your pawn from one end of the chessboard to the other end. During the process, maybe the pawn becomes king and whatever. So now let's go and do that same thing here. So we were here. So we said we do what? We make a fraction. We have a fraction. So I have sine square of x. We multiplied it by 1 plus cosine of x. And in the denominator, I had 1 minus cosine of x times 1 plus cosine of x. So what did I do? Algebra. Haven't done anything real yet. Then numerator is sine square of x. So now the challenge is just patiently type stuff. Cosine of x, denominator is now sine square of x. So sine square of x what did we do? We applied Pythagorean to the denominator. Are we right? Hopefully. No. Oh, we were maybe premature, so let's go back. So that's the problem of too many things at the same time. So let's see. I had let's see. I have to write 1 minus cosine square of x, so that another algebra. So I'm indicating I have my algebra. Now I write sine square of x times 1 plus cosine of x. Denominator, you want sine square of x. So what did I do? Now I say I'm doing Pythagorean. So I couldn't do two things all at the same time. That was the issue. Now we apply again algebra. We just write as 1 plus cosine of x. That is just algebra. So that it doesn't complain. Now we go ahead and write this thing as 1 plus, and cosine is same as 1 over secant of x. Is that right? That is our reciprocal identities. You remember the reciprocal identities? Cosine, where's cosine? Cosine here. Cosine is 1 over secant. Is that right? So we have reciprocal. Now let's see if it's gonna like what we do. So I'll have secant, secant of x plus 1, plus 1, and denominator is secant of x. So we took a common denominator. What is that activity? That is just algebra. That should conclude everything. And okay, hopefully so it's concluded. So that was another example, one rule at a time. Mention what is it that you're doing, become good in typing essentially, and think of it as playing a little game of some kind of a board game or little puzzle game or something. Plan out where you want to go. So that, where does that come from? By a lot of practice. There is no shortcut to that. How do the computers do it? The computers make it even more complicated before they actually solve it. So that brute force there is something different. What we are doing here is, by a lot of practice, getting a sense of these functions, letting them to kind of become our friends, and then we can manage it. So hopefully you learn the game. Okay, as I mentioned, there are many other identities coming up. The ones that we have done 1 through 7, these are like the basic identities with what we learned with algebra, quotient rule, reciprocal rule, Pythagorean rule. That's all there was. Many other identities coming up, so you want to wait for those. Until next time, good luck and God bless.